Hello everyone, I'm Adeeba Rashid, the team leader of Group 5. In this video, me and Abdullah will be explaining our whole project, which is indoor temperature and humidity prediction. So the data that I've used is weather forecasting, and we have started with importing libraries such as NumPy and Pandas. I've used an alias such as NP for NumPy and PD for Pandas, so on and so forth. As you can see here, now we have just read the file, that is a data set. After that, I have used dot head function, which will eventually show the top 5 rows from our data set. Then in order to view the columns, I've used dot columns function. Then after that, we are predicting temperature without humidity because temperature does not depend upon humidity. Then I have just used the columns to view the columns. And after that, in order to view the total number of rows and columns, I have used dot shape method. After that, describe method is which will eventually describe like count, mean, standard deviation, minimum, likewise. Then info method will be eventually telling us what is the data type and the null and the non-null values which are present in my data set. After that, I have just viewed what are the null values in my data set. And then I have calculated the ratio of the null values. So as you can see that the present precipitation contains 0.54. So I'll be replacing it with the most visible value and we'll be checking again. So after that, we'll be getting 0%. Here I have used 1 for rain and 0 for snow. We plot temperature column in which we predict and then split our data into training and testing set. So we'll be using 80% for training and 20% for testing as mentioned here. Then again, we have just viewed top 5 rows from our data set with dot head function. And then we are just building our model. And I've used linear regression here. We use training and testing data. So here training data and testing on this data. And we get an error of 0.926. And then we visualize our result. So this is how it looks like. From here, Abdullah will be explaining.
0 and random forest regressor with max depth equal to 10, the error will be 0.058, and with max depth equal to 50, we have error equal to 0.051. For the second step, we will predict the humidity, but this time we will not delete the temperature column, and we did the same process. As you can see here, the description, the data type of the data set, check for if there is any null values, and replace it with the most visible value, that is rain. And after that, check again and replace rain with 1 and snow with 0. And here we pop the humidity column, which we will predict, and then split it into train and test data. So first we started with linear regression, so we have error equal to 0.020. After that we moved to polynomial features with error equal to 0.012, and after that we have the decision tree regressor with error equal to 0.019, and the random forest regressor with max depth equal to 10, the error equal to 0.010, and for the random forest regressor 009. So in the last and after the previous experiments, we can say that the best model is random forest regressor with max depth equal to 50 to predict both temperature and humidity, because the prediction values almost match the actual values.